M5 is a place I come to do my lab.
Come down here, do some projects, do homework, come hang out with our friends, play some foosball. You know, it's a place for all of us to hang out.
What can I tell you about M5? It's just a place where you can hang and then build anything you want. So which is really good for EE and CS.
And you can print for free.
Yeah, you can print for free.
Yeah, it's very important.
It's very important.
Well, I think it's just that we have a lot of tools here where we're free to use, and like I'm free to use whatever's inside this box. There's like parts rooms where I could just borrow stuff, and I mean
M5 offers everything. That's kind of the point of M5. It's so open-ended. It's not really. Should I be looking at the camera? Yeah, it's so open-ended. It's it's I mean, it's not really just an academic place. It's not just a project space, as we tell people it is.
Yeah.
Usually we say it's a project space or it's a hacker space. It's also a performance space. We often hold open mics here. We have events. It's also a classroom. We have a bunch of classes here, including the experimental college classes, which are students teaching other students. We have classes which are certain professors teaching other students. I mean, all sorts of classes. We just have supplies, resources, ideas. I mean, M5 is whatever you want it to be, really. I come here to eat food every now and then. It's my dining area. I've slept here a bunch, not overnight yet, but just during the day.
That's good.
Do homework,
Hang,
come hang out with our friends,
build anything you want.
play some foosball,
Build circuit.
just borrow stuff, and
You can print for free.
do some projects.
Projects.
Project I'm working on.
Project.
Project.
We good? All right, cool. So what we had to do is we were in collaboration with the UMass Theater Department, and half the project that I did was we needed to design a clock to go to predetermined times by the people who were running the show. So one of the first things we thought we'd do is we'd take a regular clock and a Lego motor, and when we kind of just put it together, have everything zip around. We realized that this method was a little too simple, so what we did was, over on the video here is the final product, which is an analog clock, but it's run digitally on the back through just a bunch of codes that we had interfaced with an Arduino, pretty much a bunch of print lines. So what we did was the Arduino sent those commands to the clock, and the rest is history. It worked, we were successful, and it was a good job.
We're here at Circuits and Code, and we're presenting our MF5 project. Up here we got our beautiful GUI that's transmitting to our motors and stuff. We have motor control from this controller over here. So if I pick this up, you should hear a loud noise.
Alright, Mike.
Go again.
You want to get some?
Go again.
I'm trying.
You're trying. Nice.
Also a video. Over here is Emma.
So this is Emma.
Yeah, we got our H bridges, the motor control. Got our 485 bus.
Wow, whoever designed those is like a genius.
That would be him.
Yeah. Oh, you're ruining the video. Come on. What?
Nice.
Hooked up through a solid state switch.
Isn't nearly as far along as MF5 is. We've had one semester to work on it. So, but I wrote the GUI and the server side, and essentially does the same thing that they had going there, because we have the video output, and we decided to go with a joystick instead of a controller for our. But besides that, right.
So robots like Proteus 5 are actually going to be getting like a network radius from AMA, so that the robots can travel even farther.
In like groups.
And, yeah. So it's like AMA 5 is going to be like the mothership for all these small robots that we're going to have walking around campus. So that's going to be providing all these connections so that the robots can travel even farther and everything.
Proteus 5 is being designed to be very low power, so like you see their big black computer over there. Ours is very small, right? It's much smaller, and eventually we're planning on putting solar cells on it actually too, so it's right.
I'm working on a project for the Springfield thing. Right now it's really just a MIDI decoder. The MIDI messages are being produced with Arduino, and they're being decoded and through the general MIDI standard, and they're essentially using the traditional general MIDI sounds, and they're just being output to this headphone jack, which I'm putting in right now.
Oh, nice.
And then soon I'll be controlling them using this DS touchscreen,
nice.
which should be really cool. So hopefully I'll be able to maybe split the top half into whatever sounds I want to choose, and then the bottom half, maybe I'll be able to get some sequencing going in there, or just the notes, or I don't know, I haven't decided yet.
So this is an EKG, do-it-yourself EKG.
Do-it-yourself EKG.
Yeah. So it's supposed to read my heartbeat, but right now it's not. I need to do some more. I need to do some more work on it.
Okay.
But so far so good, because I'm actually using the function generator, and this is a sine wave I'm putting in, and I'm getting a sound wave out, which is good. I mean, I'm reading something, so.